So I guess I would start back when I left high school. I came up to the Kootenays to go snowboarding for a season, and that's when I met Ian. He was away hitchhiking across the country, and his roommate rented his room out to me, and then he came back and he helped me move out onto the porch so he could have his room back. And then he got me a job at the ski hill, and we've been friends ever since. So he moved down to Vancouver and started a skateboard company, and I came and helped him with that. And then he introduced me to a friend of his who had a lot of skills working with CAD software. So I went and joined him for a couple of years in Prince George, and we made skateboard molds, and I started learning about CNC technology and how to control CNC machines and make the skateboard molds that we wanted, that we couldn't get made elsewhere for a reasonable price. So Ian had moved out to Montreal and started manufacturing some other unrelated products out there, and invited us to come and join him and make skateboards. So we went out there and we started skateboarding more and manufacturing more skateboards and developing more technology. So I stayed for a few years and did that with Ian, and then I came back to the Kootenays, and Ian carried on out there.
Yeah, all the knowledge gained from that your skateboard phase.
Yeah.
How has that applied to 3D printing, 3D printed concrete?
Well, the design side of things has just given me the skills to use the software to make designs, and then also the CNC side, the CAM side of things. The technology, the skill set's interchangeable with what we're doing today. So
all of you all seem to be very entrepreneurial in that sense. It's like you just figure it out.
Yes, a lot of the challenges at the time it was really expensive, this kind of technology, so we had to figure it out and learn it ourselves. The materials that we're using, they come in two varieties for the most part. One component material and two component material. It's a 1K and a 2K. I think that's because it's a German composition or something like that. Yeah. So the 1K has everything in it. It's a powder. When we receive it and we mix it with water, has all the ingredients in it to make it give it some strength before it starts to set, before it starts to hydrate, and then you can build on. It's kind of a slower material. It's a lot more forgiving. Your water content can be a little bit more off or imprecise. And then the two-component material is a much more watery or liquidy when it's mixed with water, and then you use an accelerator mixed right at the nozzle.
Hardens much quicker.
Hardens much quicker on demand. And you can vary the amount of accelerator you use depending on what you're trying to achieve with overhangs or...
Okay, so it offers you more of, I guess if you want to explore different designs, the K2 is a more appropriate material.
Well, you can definitely do more, achieve more challenging objects.
Yeah.
You can go overhangs. The 1K material is not very conducive to overhangs.
It's better for just simple
for
forms,
vertically
straight,
stacked material beads.
So it seems like you all have explored a lot of different applications of 3D printed concrete panels, outdoor furniture, houses, and even inside, like a sink and table legs and all that stuff. You're exploring all different applications.
Yeah, we sure have.
Which one has the most potential in the future?
The most potential in the future? Well, there's definitely low-hanging fruit. So there's things that you don't need an engineer involved in, and I think that stuff's going to be. I think it's going to explode.
Yeah.
Landscape architecture,
landscape,
sculptures, artistic things.
Yeah.
I think that stuff's going to really accelerate. And then when we see more engineers get involved in structural, then we'll see more of that stuff start to happen, I think.
Like y'all were talking about with the Fibonacci House, you had everything done for 6,000 Canadian dollars in a few weeks, 5 weeks?
In a few weeks, yeah.
5 weeks or something like that. And then you just have to wait for everyone else to come by. The carpenters, the interior finishers, and everything else. Yeah. So you're saying something where you have sole control over the final outcome and you don't have to wait for other people that's where people are really going to take advantage of this
I think
technology.
so, yeah.
First.
I think when people can make their own decisions and
produce things much quicker.
Yes.
Yeah.
Yeah, I think so. I think that's going to go a lot faster than the other stuff. But I mean, eventually the other stuff, the structural stuff, homes, buildings, things like that, bridges, whichever, is going to catch up as well.
So what's the goal of Twente Additive Manufacturing?
Oh, geez. We've got a lot of objectives here, for sure.
What's the primary goal? I don't know if you'll have many.
Well, I mean, really, we want to make a lot of cool things. We want to build houses. We want to reduce waste. We want to push the envelope in a lot of frontiers.
Okay, not one particular outcome, but several different.
Several. I mean, there's lots of things to improve upon right now. Whether it's the machines, we can push our material suppliers for better, more versatile performing materials.
So y'all constantly give them feedback. Hey, this mix isn't perfect. What if you add this stuff? And then they come back with that.
Or we use their material and we say, well, what properties would we like to improve upon?
What about with the machine itself? Are you all trying to get like a proprietary nozzle design? In that sense, are you focusing on the design? Are you focusing on the machine?
We're focusing on a lot of aspects.
Different things.
Yeah, so we're focusing
on. But like 10 years down the line, 20 years down the line.
I don't really think we're going to be stuck in one particular feature or development. I think we're going to be working on the software. We're going to be working on the equipment. We're going to be working on the designs with partners, with designers and engineers.
Yeah.
So I don't really know exactly where it's going to take us.
Yeah.
Which subset is really going to win. Right now, there's just so much development to be done on all the aspects.
So do you all see yourself being like a research and development team, like kind of like what we discussed earlier, and y'all are y'all aid experts in different fields, like you aid the engineers, you aid the people, like you help the people making the mixes or making the printers themselves? Y'all see yourselves like a jack of all trades, helping different professionals?
Yeah, absolutely. We haven't really, we're not going to push the other machine developers to build better machines, but we definitely will be building our machines
Your own machines,
improving our machines, the versatility, the speed, the accuracy,
yeah,
the cost. The user interface is a big one right now, because
it's still very
doing
technical.
This stuff is very technical, and you need to have a lot of skills to be able to perform properly.
And training other people who don't have the knowledge that you do is very difficult.
It is, because there's a lot of basic skills and understanding that you need in order to move on to the advanced stuff.
Yeah. So it's not something you can really dumb down into like a 2-week course and hey, you become an expert in how to use this machine so quickly.
No, you can't. But there's there's some knowledge that you can learn right away in order to participate.
Yeah.
So you don't have to know all of it to be able to get involved. As you can see, it's more than one person at a time with the printer. It's a team, whether it's the design, the coding, the slicing, the machine operation, cleaning up, taking care of the prints after they're printed, transportation of the items afterwards.
Do you all see yourself being, setting up some sort of like university degrees in 3D printing, 3D manufacturing?
We haven't really discussed that too much. I've heard of some other schools out there. I don't know if they're actually started or not yet, but I've heard some ideas about 3D printing schools out there. But
I think that could actually be a degree. I mean, they're engineers, structural engineers, they could be 3D printing engineers, and then you have specialized fields within that realm of 3D printing.
There's definitely
whether it's the software, whether it's the maintenance aspect, like even the cleaning up or the assembly of stuff. They're all like they could be highly specialized fields in the future.
Yes, definitely.
Yeah.
Yeah, well,
he briefly mentioned it.
Well, there are universities that are taking a great interest in this technology, and they are developing a lot of the things that we're even using today. So they've forged the techniques that we're some of the things that we're using right now.
So what's the future in Canada or in Nelson? You're trying to bring more awareness about 3D printing in this area?
Well, I mean, it's more of a global awareness that we're after. We do a lot of research and development here in Nelson. So a lot of the industry is elsewhere. as you can see, we're in the forest here, and it's a great place for the prototyping and development. It's very challenging here, so there's a lot to be learned here. I would say most companies are either using 1K or 2K.
They don't experiment with both, like they find...
Not in particular. I would say the universities are mostly focused on the 1K as far as I've seen.
That's surprising. I thought they would be more in the 2K because universities kind of push design and experimentation.
I'm not really too sure why not. Other than maybe it's quite expensive. It's quite expensive to get involved in the 2K.
How much more expensive, like for a particular volume of concrete?
Geez, well...
3 times?
I would... The mixing technology to introduce the accelerator to the material is...
Because you have to consider the nozzle itself.
As far as I know, it's all patented. I don't know of any open source or non-patented 2K mixing technology.
But K1 is pretty open-ended, right?
K1 is typically just a pipe. There is a lot happening at the nozzle.
Yeah.
In terms of the shape and the design, and in order to get your beads to behave a certain way, but for the most part, yeah, 1K is quite simple to apply.
So you think it's just a matter of time before K2 becomes the same? Like there are more people?
I think so. I think there's going to be a lot of people. Once the technology matures more, the material cost is going to have to come down on the 2K side.
So you all talked about the cleaning up process and how it's not really discussed much, and how it's extremely tedious and time consuming and has to be done like diligently every time.
Yes.
And I think that could be a big barrier for many people, because a lot of people don't want to do that. They just want the sexy part, they want the print, and then they're just going to ignore it. But you have to take care of the machine and treat it properly and all that stuff. So how could they make that part easier in order to make the technology usable?
Well, we're definitely keen to go ahead and develop equipment that's easier to clean, that's more streamlined, fewer parts.
Because you don't want it to just be disposable. That's an easy way out, because then you just throw everything out each time, make it out of cheap plastic.
It's expensive too.
It's expensive
and maybe you
and
can't
wasteful.
reset it as quickly. Yeah, that's a very expensive way to go.
Yeah.
Not really sustainable.
Yeah. But just parts that are fewer parts and easier to clean or something.
Well, yeah, more simplified, more streamlined, more... I mean, a lot of the equipment that we're using right now comes from other technologies, from plastering, from shotcrete, from screeds for flooring. So there's not a lot of equipment out there that's specific. And it's starting to come around. And I mean, one of our niches, one of the things that we've really put a lot of time into is the pumping equipment and add-ons. There's a lot of features in a mixing pump that aren't necessarily mature right now, so we're pushing and developing those features and adding them to our own equipment.
So you know the home printers, that the PLA filament printers.
Yep.
There's a guy, Joseph Prusa. He makes like the Prusa printers. So he's kind of like he made this open-ended printer where you can just buy certain parts, open source printer, and then you can interchange. You can interchange different parts and make it bigger, make it smaller, build the printer that you want.
Yes. Yeah.
Is there a company out there trying to do that with 3D printers, or are we not there yet? I mean, we really have to push.
I would say we're trying to do that.
You're trying to do that.
We are doing that. Yeah, we've got a mobile printer. We started with a 9-axis gantry printer in our workshop. Yeah. And we can print things that we can't move. They're too big. There's a lot of compromises in your design in order to make it transportable. So, I mean, yeah, we put a robot on a trailer, and now we're building our own trailers. So, absolutely, interchangeability.
So you can buy just the
robot,
arm, and then you can use your own trailer. You can buy just the nozzle, use your own robot arm. It's all. It's
we do quite a bit of customization for our clients right now. They're always asking for. I mean, everybody wants to do different things. You know, landscape or structures or architect. Yeah, those things. Yeah. And so each of our clients wants particular features or configurations, right? So not everybody needs a robot. So there's a gantry. 3-axis gantries are quite a plain, simple approach, which can be a lot more affordable. And,
instead of a 6-axis.
Yeah, as opposed to a 6-axis or more than 6 axis as well.
Do y'all make that?
We don't make the robots.
No.
No.
Is that something y'all maybe
some
teamed
really-
up with? No.
There's experts already in that field,
Yeah.
and we don't really feel like we need to improve upon that at the moment. So,
So is it that
there's
y'all
definitely
connect-
integration issues with these robots.
Yeah.
That it turns into quite a niche application of these robots that we're going to be pushing these robot manufacturers to help us with or to integrate for the features we're after.
Okay. So you kind of you meet the clients, you figure out what their needs are, and then you tell them, okay, you maybe pick this component, this and this, put these 3 components together
Yes.
for your particular need.
For their needs, absolutely. Yeah. Some people want to build tiny homes. Some people want to build big, subdivisions. So there's not a one printer fits all necessarily.
Yeah, so your role in the Fibonacci House, and I know it was a collaborative effort,
It sure was,
all of
yeah.
y'all, the design, y'all came up with the design
We did.
in a matter of days, weeks.
Yeah, I think it was moments even.
Moments.
And then we kind of refined it over days and weeks, and so it was one of our first big projects, and we did a lot of research and development in printing that house. So there was a lot of development of the house actually while we were printing it. My role in that, is probably from the design to the installation. I even did a bit of carpentry in there after everything was already in place. So
Yeah, the beams, I think, right? You used
The
your
glue
knowledge
beams.
from
yeah, I
your
used to
previous.
work for a timber frame company.
Yeah, and you used that knowledge towards positioning, like placing the beams, or
Well, I used
you actually.
my understanding of how to build,
Yeah, in
construction
that.
knowledge in influencing our team in our design for sure.
Very cool.
Yeah. So we printed. I helped. I mean, I was there every step of the way printing that, and figuring out how we're going to transport these pieces, and modifying our printing after we tried to move the first couple, and just lifting apparatus. These pieces aren't straight and square, so every piece is unique and needs a different lifting strategy.
That's true. That's the big hurdle of printing it in a factory and then transporting the site. How it's being transported, especially irregular shapes.
Yes.
And also the cost. It's convenient for you all because you had
It's
to install
close,
it
but
right
yeah,
there.
yeah.
But if you had to install it somewhere else, somewhere else in Canada or in the States or something, that would be really expensive.
Yes.
So that's what, so then you would consider printing it on site rather than in a factory.
On site or move the factory. We can set up a temporary factory at a subdivision or a site, right, as well.
There are a lot of advantages to printing in a factory rather than on site. Controlling temperature, humidity,
Yes.
keep it away from the elements, letting it cure in controlled conditions.
Sure is, yeah. Well, you can do other aspects too. You can integrate your insulation, your mechanical, electrical, plumbing, all that stuff in a factory setting is typically a lot more efficient and cost effective.
But then, so in the future, I know there are a lot of people pushing towards printing on site and just putting up a large tent over their plot of land and then printing it over there.
Situ, yeah.
But that is expensive. Tenting of the entire site is.
It seems to be.
It seems to be expensive.
I mean, maybe somebody's going to come up with a more cost-effective way to do it.
Yeah.
Something that's reusable, easier. But the other side of things is that hopefully we're going to get better at printing in the environment.
Yeah.
The material suppliers can help us with
More resilient.
more resilient materials.
Yeah.
Printing at night and then during the day. We just
Temperature
recently completed a
fluctuations or
project in
something.
Dubai. Our team over there was
Yeah.
printing in the evening because of the environment. So
Was too
for sure
hot.
we're going to be discussing with our material supplier what sort of challenges and what the features we do like. Where it did perform well for those conditions and continue to develop the material with them.
I guess that's the big thing because they can make all this stuff in their factory, but they don't know exactly how it performs in different conditions around the world. So they need that feedback from you all.
Yes, yeah,
that's vital because otherwise they'll just be making the same thing over and over.
And
they won't know what to change.
And there's times when they make changes that are less desirable. So feedback to let them know that wasn't
hey, your
necessary.
previous iteration was
we
better.
want to go back.
Go back.
Yeah. There's a reason to print in situ, and there's a reason to print in a factory, and there's going to continue to be more reasons to do both. So we want to get better at all of it. So my day-to-day out here can be, from printing to preparing to installation. There's a lot of site work that needs preparation for printing, whether it's excavating. I can jump in the loader or the excavator and help get things ready for the print. There's a lot of fabrication. When we're building a printer for a client, I can do the drilling and tapping and fabrication work required. Designing of all kinds of different things, whether it's the printing equipment or the pump or the printer itself or the parts. It's really excited about geopolymers. There's a lot of waste materials, hazardous materials that can go into that and be reused. There's a lot less energy required to come up with the raw materials. They're a lot more resilient to a lot of things like heat. There's fire ratings for these things. There's longevity, chemical resistance. The geopolymers are really exciting field of materials that's emerging. I mean, I see some of these materials were used by ancient civilizations, and some of the things that are still around have been discovered to be geopolymer type materials rather than conventional blocks of from a quarry or something like that. They were actually poured in place, some of these things.
Is that like the Roman concrete that continues to cure over time?
I don't know about the Roman concrete, but it sounds like there's some megalithic objects in Central America that have been evaluated and looked at under a microscope, and there's aggregate in a binder, and it was previously thought that was
a stone
cut from a quarry. But of course they couldn't find the quarry because it wasn't.
It wasn't.
So I hear stories, I don't know exactly what's true or not, but I hear stories about ancient civilizations using things like fruit juices to dissolve sand, like a powder.
Oh, wow.
I guess they would take rocks, grind them up into a powder, and add, whatever kind of acidic or alkaline chemicals they had at the time, and it would, create a geopolymer.
They probably didn't call it that, but
yeah. So
that
don't
makes
quote me on
sense.
that, but I've read a bit about it from Joseph Davidoff and the geopolymer crew there, and what they're doing is really exciting, and I'm always
like when we
paying attention when they're speaking.
Look at the frescoes made in Florence and Italy and all that stuff, and they look at the pigments that they used in the frescoes.
Okay.
That was all ground up rocks, or like the ink and all that stuff was like the indigo ink was from, I don't remember exactly where, but it was all from stuff around them. They would just try to figure out what would give them the color they wanted. Yeah. And then I think they used like an egg wash or something to over the paintings to protect it. So it's all these, and it's lasted for thousands of years. Yeah. And it's protected.
Yeah, we
these
think we know it all now, but there's a lot of stuff happening before that.
It's kind of like lost art.
Yeah, it is kind of like lost art.
So geopolymers is one of them.
It seems to be, yeah. I mean, I can't imagine it was a technology that was shared around the world, but it seems like there's been different civilizations that have discovered and utilized it in their own, with their own materials in their own environment. Mm-hmm.
We were talking about you should build a 3D printed Stonehenge over here, right here. It seems like the perfect site. You already got some of the rocks out there.
We're going to need a message. We need to incorporate something clever into it. Either like meridians or some kind of astrological features.
Mm-hmm.
Because
of your experience,
I don't think I'm the most knowledgeable. I would say that, we all have our experiences, right? So, like Tim's got quite a bit of experience with concrete that I don't have. My experience in construction, I was a laborer when I was 15, working on a construction site, so I learned quite a bit from those guys for a few years there. But then I worked for a timber frame company, and we had a big CNC machine for doing all the joinery on the big timbers. And I didn't really get into the finer hand, skilled labor of it, but the technologies, and of course the application was for large scale, typically more expensive construction. So I've got my niche, I've got my, but I wouldn't say that I'm the most knowledgeable, but I'm definitely I've definitely got some understanding that some of the other guys are not as strong with, and they also have
Other niches
other niches
that you're
that
yeah.
we're I would say we're a great team in that sense.
A lot of knowledge sharing going on
We
in the
have a lot of
company.
knowledge sharing, and we help each other out and share ideas when we're developing things.
What about, I know y'all are privately funded right now. Y'all are, you're looking for investors to scale up?
We're definitely considering it.
Yeah.
Absolutely.
It's expensive machinery and
It's very expensive. Being self-funded, we've been able to self-direct as well, right? We haven't really been beholden to anyone else's objectives other than to do it the way we want to do it, or the way we want to learn, or focus on the aspects we feel are going to be that need the most development.
it's very tricky because you all still want to be creative and test out all these different things, but all that's expensive.
Yeah. So we'd be looking for someone, a partner who's
equally creative.
who would be able to help us advance. Not just anybody with money, but we need somebody who's maybe got some skills or resources that would complement what we're trying to achieve.
Thank you so much.
You're welcome.
Yeah,
Thanks for coming to see and
showing the factory and the house and everything that y'all are doing over here. It's so inspirational.
Great.
It really is.
Yeah.
And you have this beautiful surroundings that just provides you with challenges, provides you with opportunities, and just keeps pushing you all.
It sure does. Yeah.
Like what else can we do around here?
Yeah. Boy, we've got lots of ideas.
Yeah.
And not quite as much time.
Yeah.